It's adorable.
Oh, there it is.
That's my cat saying hello.
This episode is sponsored by Hired.com. Every week on Hired, they run an auction where over 1,000 tech companies in San Francisco, New York, and LA bid on Ruby developers, providing them with salary and equity up front. The average Ruby developer gets an average of 5 to 15 introductory offers and an average salary offer of $130,000 a year. Users can either accept an offer and go right into interviewing with the company or deny them without any continuing obligations. It's totally free for users, and when you're hired, they give you a $2,000 signing bonus as a thank you for using them. But if you use the Ruby Rogues link, you'll get a $4,000 bonus instead. Finally, if you're not looking for a job but know someone who is, you can refer them to Hired and get a $1,337 bonus if they accept a job. Go sign up at hired.com/RubyRogues. Snap is a hosted CI and continuous delivery that is simple and intuitive. Snap's deployment pipelines deliver fast feedback and can push healthy builds to multiple environments automatically or on demand. Snap integrates deeply with GitHub and has great support for different languages, data stores, and testing frameworks. Snap deploys your application to cloud services like Heroku, DigitalOcean, AWS, and many more. Try Snap for free. Sign up at snapci.com/RubyRogues. This episode is sponsored by DigitalOcean. DigitalOcean is the provider I use to host all of my creations. All the shows are hosted there, along with any other projects I come up with. Their user interface is simple and easy to use, their support is excellent, and their VPSs are backed on solid-state drives and are fast and responsive. Check them out at DigitalOcean.com. If you use the code RubyRogues, you'll get a $10 credit. Hey everybody, and welcome to episode 235 of the Ruby Rogues podcast. This week on our panel we have Jessica Kerr.
Good morning.
Avdi Grimm.
Hello from Tennessee.
David Brady.
Do not get me started about units of weights and measures.
I'm Charles Max Wood from DevChat.tv. Quick shout out for JS Remote Conf. Go check it out. We also have a special guest this week, and that is Rob Miller.
Hello from a very windy and chilly London.
Do you want to introduce yourself?
Sure. I'm Rob Miller. I live in London, where I work for a marketing company called Big Fish. I love Ruby, and I just published a book called Text Processing with Ruby, and I think that's what we're going to talk about today.
I was going to say, our topic is text processing with Ruby, and what qualifies you to talk about this, but you beat me to it, so...
Sorry.
Do you have a place that you like to start with this topic?
Like A?
Sure. I mean, I could start with my motivation for why I wrote the book.
That's a good one.
Rob,
Sure.
why did you get into text processing with Ruby?
Well, it was actually accidental. I got into text processing because my job frequently demands me to manipulate lots of data. You know, system A has data in this format and it needs to be in system B, or there's this big amount of data, but it's on a website that has no API, so you need to scrape it or something like that. And I got into doing it with Ruby because I love Ruby and enjoy programming in it.
So why does text processing matter? It seems like it's pretty straightforward as far as, oh, I've got a string, or oh, I've got some paragraphs and I want to munge it. You can break, you can join, you can do all kinds of nifty things in Ruby. So since Ruby makes it so easy to manipulate strings and things, why write a whole book on text processing?
Well, I guess the thing is that so much data in the world, so much stuff out there is in a textual format. It's not in some structured database that's really easy to consume and manipulate. It's just raw text, because we as humans, linguistic animals, and produce lots of text. So it's frequently necessary to go out there and process stuff that exists only in raw, big blobs of text. And then there's so much you can actually do with that, from passing out little bits of structure from that text through to doing natural language processing, interpreting it as actual structured English language. And it's just a really huge field with lots of useful things you can do in it.
Do you prefer the term Markov chain or drunken walk?
Markov chain, I guess.
Okay, all right.
I've never used one except to make ironic Twitter bots. I think that's probably their only general use, isn't it?
I actually built a gibberish bot once that used text processing, and the Markov chain was actually at the syllable, at the phoneme level. So it would basically take, like consonants and vowels, and then it would string them back together into randomly mixed up words. And so you would get this garbled stuff, but you could pronounce it.
Yeah, but it would do it in a pronounceable order because it's the same syllable order you find in the source text. Oh, that's cool.
Yeah.
Seen similar for like password generation stuff where you generate a random, very long string of characters for a password, but you make it pronounceable in the same way.
Right.
It's cool.
Right.
That actually sounds really weird. I don't know why, but it does.
I'll pull out the Markov chain stuff that I wrote and show you, Chuck. It's a lot of fun.
Give us some examples of gibberish.
I've got a friend who draws Schlock Mercenary, and those watching the video, I'm wearing a Schlock Mercenary t-shirt, which says Maxim 34. If you're leaving scorch marks, you need a bigger gun. And the aliens in Schlock Mercenary, it's set 3,000 years in the future, and Howard started giving weird names to his aliens. And so I started talking to him one day, and I said, give me the general vowels and consonants that these aliens would speak with. And because he introduced a character named Chavorthka, and I'm like, okay, this got glottal stops, it's got this, whatever. And he gave me like 10 or 15 things for frequencies. And I turned around and generated entire books in Chavorthka's language. And it looked like it was his language. I mean, it was plausible. Like if I take this, if you don't speak German and you run Markov chains on German words, and then spit them out as letters, a German will go, what the crap is this? But anybody who doesn't speak German will go, oh, that's German.
I frequently encounter a kind of junior developer who's only ever really done web development that struggles when they come across these text processing tasks. And the worst outcome of that is that they end up not enjoying them and viewing it as a kind of drudge work or something that isn't actually enjoyable. Whereas I, perhaps because I'm strange, get quite a lot of enjoyment out of turning some big block of inert text into some valuable and interesting data. I find that actually quite rewarding. I've always been more drawn to the kind of the practical getting results side of coding than towards the theoretical side of things, I guess. Mm-hmm. So the aim, I guess, with the book is to hopefully make it so that people feel as enthusiastic and interested in what can often be viewed as a slightly boring area necessary area. It's actually quite interesting, and there's tons of interesting areas that you can plumb into, especially things like natural language processing and writing parsers and things like that.
What in the book that you've put in there do you find yourself using the most often?
So the thing I use most often since developing the skill whenever I did is probably the kind of ad hoc exploratory sort of data processing on the command line, like throwing together shell one-liners. Like very often the type of work that I have to do, it's a one-off. It's a kind of write once, run once type of data processing. You just want to figure out what the data looks like or answer a quick question or even kind of understand what question you need to ask and then later on ask that question in a full-blown script. So that kind of harnessing the existing Unix tools that are out there, throwing together these pipelines that are actually quite quick to create but become suddenly incredibly powerful and can chew through enormous quantities of data really quickly. That's the point where I feel most productive and kind of you get that kind of Zen master feeling of like, wow, I'm actually like, I've just written that in 5 seconds, but it's amazingly powerful and capable.
I kind of feel like that's almost Ruby's core competency. Maybe I'm on the fringe thinking that, but...
No, absolutely. I mean, Ruby existed for, 12 years before Rails even existed, I feel. And if you look at Ruby's Perl heritage as well, I mean, Ruby was a general purpose programming language with a huge emphasis on text processing and that general kind of day-to-day ad hoc stuff for longer than it has been a language that is viewed as primarily centered around web development, I guess. So it has more of that in its heritage than it does web development. And I feel like it's even more, as suited as it is to web development, it's even more suited to this sort of task.
Yeah, I mean, for those who don't know, one of the big reasons Perl was created was the idea was take all of the little tools that are included in the Unix command line for munging text, like sed and awk and tr and grep, and, tail and all these things, and sort of put them together into a programming language that makes them easier to glue together. And then Ruby basically just copied all of that in its entirety from Perl.
Yeah, absolutely. And I think it's quite telling that Larry Wall, creator of Perl, was a linguist. He has a linguistic background. It came from that whole heritage of processing text and understanding text and language. Perl to me feels like a very language-oriented programming language, if that makes sense. Mm-hmm. If there's some kind of spectrum that programming languages exist on between very linguistic ones and very mathematical ones, Perl and Ruby both occupy a very extreme position at the linguistic end of that spectrum for me. And that's where I personally enjoy playing, partly because of my background and partly because of just it's what interests me. I have much more interest in that expressiveness and the language that you get with Ruby and Perl than I do with Haskell or something like that at the other end of the spectrum.
Right. When people think these days about chewing through a lot of data, a lot of times we automatically think about big data sets that are in something like JSON or CSV, or even just sitting in a database or something like that. Where do you often find that you have to chew through less structured data using these kinds of techniques?
All the time, unfortunately. I wish that I had to deal with nicely structured data more often. I mean, very often it's exports, like for better or for worse, kind of CSV has become the lowest common denominator export, but it's also things like unstructured data entered by users into websites, into free-form text fields, comments, and things like that. And it's really often data that's out there and exists on websites and exists in the world, but it's not available in a nice, clean, even a CSV file that you can download. It's just embedded in a website that's intended for human consumption, and very often a website that was made with Microsoft Front Page in 1997 or something. I just frequently find that the data I need for my day-to-day job is in that raw, unstructured, horrible form, and I have to try and chew through that. It's not necessarily that the data sets are huge in a big data sense. They almost never are. But then I guess for most people, most data sets they deal with aren't huge in a big data sense.
Somebody's going to have an issue with you saying that CSVs are somewhat unstructured. But
they're not unstructured. They're just always malformed.
Yes.
Yes, absolutely.
I was trying to think of the right way to say that. Thank you, Dave.
They're definitely structured, but it's harder to do things with them than things that are in a relational database or something that's really easy to query. So it's very often you have this ingestion step where you're just taking in a whole lot of that data and then you're having to query it using Ruby, or, you're doing kind of stream-based processing where you're just processing it record by record and things like that. It takes a different approach than data that's out there in a database or something like that.
Yeah.
So one thing that we talked about a minute ago was the command line tools. So the shell one-liners that you talked about. Uh-huh. This book's about Ruby, so do you use kind of the wrappers around those one-liners in Ruby, or do you actually use the command line to munge some of the data to a certain point, and then when you need something that's a little bit more intelligent or a little bit more intelligible, to pull in something else that's...
Yeah, almost always the latter. So, I mean, another one of those amazing things that Ruby inherited from Perl is that it plays really nicely with the command line and with shell pipelines in particular. So, you can invoke Ruby from the command line and pass code to be executed in straight from the command line. And it also comes with all sorts of useful flags that let you sort of do line by line processing of input to, manipulate lines and also automatically print them out, all those sorts of things. So my approach generally, the one that I find really useful, is to go as far as I can with the existing tools that are there, the kind of the core utils, text processing tools, cut and set and hawk and cat and head and tail and things like that. And then you always get to a little bit of the problem, the little bit that's a bit too complicated. And for me, instead of dipping into awk and writing a complicated awk script, I reach for Ruby purely because it's something I know, but it's also just as capable as awk and really straightforward to put in as that one slot in the pipeline that needs to do the complicated bit. And then the rest is core utils. And that seems to be a really nice balance between having to implement lots of things yourself, and you get the productivity of all these things having been implemented for you while still getting to solve your specific problem.
Rob, how often do you use Ruby-I-N-E?
Not I very often, because I in place editing and line processing in E to fast. I use any all the time, but probably not I too often. Didn't catch me out there.
So for the listeners, do you want to go through what Ruby-NE would do?
Yeah, sure. So Ruby E is a way of passing the E option to Ruby when you're invoking it from the command line is a way to, rather than execute a Ruby script, as you normally would by saying, Ruby foo.rd, you can use the E option and pass in some code there and it executes it directly, which allows you to run Ruby code without committing it to a script. So that's really useful in those little one-liners. And then Ruby also comes with some other useful options, specifically for text processing. N is probably the most commonly used one. So N will loop over every line, either in standard input, if you're sort of piping text into the Ruby script, or in the file names that you pass on the command line after your code to the Ruby interpreter. And it will loop over every line and all of that input and allow you to process the text line by line. And line by line processing is an incredibly common thing to want to do. Lots of file formats are line oriented, web server logs, things like that. So processing line by line is really useful.
I use the -I is the modify the file in place. And I will use INE to change all of the source code in like an entire tree.
Yeah, so INE lets you do a mass find and replace across your entire directory if you want to. If you pass in sort of a recursive glob of lots of files and things like that.
Good times.
The point Abdi made about big data was an interesting one, I think, thinking about big data sets, because that's a personal bugbear of mine. I don't know whether anyone else thinks the same way, but I know it's a bit passé to harp on about, to target big data these days. And the mass hysteria has kind of passed, which is good. But you still find a lot of people thinking that they have a big data problem when they've got a data set that's, a gigabyte or two in size. And that's, that's not a big data problem.
That's adorable.
And people seem to frequently be quite amazed by the amount of data, especially if you're doing kind of stream-based processing, the amount of data that you can process on a single laptop with very straightforward tools. Most people don't have big data problems, and trying to treat a small data problem as if it's a big data problem is a road to horrible pain and suffering, I think.
Are there particular anti-patterns that people use, like naively use, that lead them to thinking that their data set is too big? I mean, like things that you find people do that just cause them to process like a gigabyte-sized data set really, really slowly.
I think the number one that comes to mind is definitely not using streaming on a problem where a streamable solution is possible. So instead of processing a large amount of data chunk by chunk, so that only one particular chunk of the file at a time is in memory, people read a huge amount of data into Ruby, end up allocating, an array of gigabytes upon gigabytes of memory. Their computer slows to a halt, everything swaps to disk, and they think, this problem is too big for a single machine, clearly. But when actually, if you think about the problem in a different way, it's very trivially solvable on a single machine. My favorite, there's an article that did the rounds a couple of years back by the data scientist Adam Drake. But it's called Command Line Tools Can Be 235 Times Faster Than Your Hadoop Cluster. I really enjoyed it. So a data scientist had looked at the results of thousands upon thousands of chess games, and he'd used a 7-node Hadoop cluster running on AWS, so like medium EC2 instances, big, powerful, lots of servers, to process this 2 gigabyte set of data. And his Hadoop solution took 26 minutes to complete, running in parallel on 7 different machines. And in the blog post, Adam Drake writes a solution that uses 3 commands in a pipeline chain that runs 235 times quicker. So it ends up running in 12 seconds on a single laptop, a single, not particularly amazingly spec'd laptop. And that's just a perfect example of framing the problem in the wrong way and thinking about it in the wrong way, when if you actually take a step back and think, do I just need to process this particular chunk of the data at one time? Can I stream it? Allows you to just chew through it almost infinitely quicker.
This is sort of broad, but I mean, are there particular libraries or methods that lend themselves to that kind of stream-oriented processing, or techniques?
For me, it usually depends on the shape of your input data, really. It doesn't have to be line-oriented, although it's obviously quite straightforward. as we were just talking about, there's lots of easy ways to do line by line streaming in Ruby, but just anything that you can delimit and only read in up to a certain delimiter at a time. So anything, it's quite an abstract thing, but anything that fits those kind of parameters, anything that you can think of in terms of chunk and only process a chunk at a time. And that might not seem immediately like it's everything, but there's solutions to that for things like, event-based XML and JSON parsing, where you don't have to read the whole JSON or XML file into memory at once. You can stream it and it fires off events when it reaches, when it encounters particular things in the input. So there's lots of problems that lend themselves to that solution, but it's generally dependent on your input more, I think, than the specific answer that you're trying to get or the specific problem that you have, if that makes sense.
Yeah. A lot of the classic Unix tools had a sort of generic concept of record, and record was usually defined in terms of some kind of record separator. There wasn't a specific one kind of record, one size fits all. It was that, you could tell the tool, this is what the record separator looks like. And at that point, then we can sort of process things in a streaming fashion, record by record, or chunks of record by chunks of record. And Ruby actually has that, doesn't it? It has an input record separator variable that you can set either from the command line or in code that it kind of inherits from Perl.
Yeah, absolutely. And then methods like getS, for example, people think of getS as getting a line of input, but what it does is actually reads up to the input record separator. So if you have, a huge amount of input that's on a single line and comma separated, by default gets is going to give you the whole input. Whereas if you change your input record separator to a comma, you can read those records in and stream them and process them one by one. And then Ruby also has the input field separator as well, which is also really useful. So if you think of a CSV file, for example, you have records which are separated by new lines, and you have fields which are separated by commas. And Ruby, just like it allows you to use the N flag to process input line by line, it can also split those records into fields for you. You can pass it the F option with a delimiter, and it will split the lines on that character, and then pass the A option to auto split. So it makes processing, tab separated data or things like that. Lots of data formats have that kind of record and field paradigm. So it makes processing that sort of data really straightforward. And again, it can be done in a streaming fashion, which is really useful.
There's a great thing in the, I'll put a link in the show notes, but if you go to I thought I was going to say it's on Wikipedia, but it's actually in Wikibooks on the Ruby. I think it's from the Pickaxe books, but they talk about the predefined variables. These are all the $ variables that are available in Ruby. And the thing that you can set with the $F field is $semicolon. So you can say $semicolon equals single quote, comma, single quote. And then you can take an input record and just say split, and it will explode it on commas instead of on white space, because that's the input. That's the input field separator. And exactly. using all of these $ extended ASCII characters will get a pitchfork and torch brigade at your desk, which is awesome if you need to know how to summon one of those.
Yeah, it's another one of those things that we talked about Ruby's Perl heritage, and there's a sort of you often encounter a sort of sniffiness about that in the Ruby community that especially manifested in the hatred for the cryptic globals, but that somehow Ruby's Perl heritage is not one of its assets. But for me, that's totally untrue. I think that loads of amazing things in Ruby were stolen wholesale and verbatim from Perl, and that's really great. And I must admit, I'm an occasional user of the cryptic globals without, requiring English or anything like that. Actually use the globals. They're useful, just not, in libraries that other people use and things like that, but they're definitely useful in little one-off scripts and things.
Chuck or Avdi, have I bored our listeners with why I threw out Python and switched to Ruby?
I don't think I've heard this one.
This is a real quick story, but when I first got into scripting, I got into Perl scripting, and I was doing a ton of IRC at the time, which is, instant messaging on the internet, and you have one line for all of your input. And I had bots that I could give code to execute, or my IRC client could be modified on the fly by sending code to the client itself. but you only have one line with which to enter everything. And I was trying to learn Python. I fell in love with Python in one day and threw away all of my Perl scripts to switch to Python. And then I discovered that whitespace dependence means you need multiple lines to enter code. So I went back to Perl whenever I was on IRC. And then along came Ruby, and you could spread out your program like Python and make it nice and readable. But if you had to crunch it down, you could. And you could write. And I've written, 1,000 character programs in Ruby and Perl on a single line of IRC.
Yeah, it's that there's more than one way to do it heritage that Ruby also inherits from Perl. There's a really fundamental philosophy in Ruby, isn't there? It's totally acceptable in Ruby for there to be 10 or 15 ways of achieving the same thing, because exactly like that, sometimes there's scenarios where one method is obviously superior to the other. It's all context dependent, rather than that Python view of, there should be one clear way to do things. Except sometimes there's a scenario where that one clear way of doing things is horrible and unsuitable, and it kind of falls down.
I don't want to kick the Python guys too hard because they kick back. But the reason I just threw Python out was I ran into a case where the one right way to do it had kind of expired. Times had changed and there was a new one right way to do it. And people were still doing it the old way because it matched all their existing programs. And the thing that I love between Perl and Ruby is they both say there's more than one right way. There's more than one way to do it. Perl, it is morally acceptable to choose the worst possible way to do it. Where in Ruby, there's more than one way to do it. Please use the most appropriate one.
Yeah, Ruby is Perl with taste, isn't it?
Yeah. Oh, I like that. I like that. Yes.
Ruby often makes the elegant way also extraordinarily accessible. I mean, I really like the way that Ruby takes a lot of these Perlisms and builds some structure around them. I mean, like we were talking about getS, getS gets the next record depending on the input record separator. But then you also have something that's more Ruby-ish, like each line. You can call each line on an IO, any IO. It could be a stream coming in, it could be a file, whatever. And, by default, it's going to be a new line delimited line, and this is nice stream processing. You're only getting a line at a time, but you can also, it also respects the input record separator, or you can manually pass in as an argument the input record separator, and now your lines, are separated by whitespace, or they're separated by some other character, but you're, using a very Ruby-ish block syntax, or you can use that without the block, and now you have an enumerator, and now you can do all kinds of neat chaining things with the enumerator, which is extraordinarily Ruby-ish, but it's also extraordinarily accessible.
Yeah, absolutely. I mean, from a text processing perspective, enumerable is my favorite part of Ruby, and the single, enumerable plus blocks for me is the single reason why Ruby is such a lovely language to use. It goes a long way to the reason why Ruby is brilliant. And from a text processing perspective, being able to combine all that power and flexibility of Perl with that, I guess, kind of functional programming influence in enumerable and all those methods that you get for free with enumerable. Because, like you were saying, each line and they're the same method on a file, for instance, which means that a file gives you all the power, a file class gives you all the power of enumerable. You can suddenly select lines based on particular criteria, or you can group them and do everything that you would expect to do with a collection in Ruby. And you can do it with the stream-based processing of text from a file, which is it's the amazing combination of Ruby's strength plus the strength that comes from its Perly heritage.
I don't usually swoon over the British accent, but I love how you say Perly.
Perly. Sorry. Yeah, I knew I was going to get mucked for my ridiculous accent at some point.
Could have been worse.
Pearl.
That was pretty good.
But coming out of you, that sounds wrong. That sounds wrong.
I mean, the reason it sounds wrong is because it is wrong. It's Pearl.
Excellent.
I also love, the fact that these you have these abstractions that kind of gradually build up as you need them, because, you have what we were just talking about with like the each line and the enumerable chaining that you can do based on that. And then you have some more like class-based abstractions like string scanner when that stuff isn't enough.
Yeah, absolutely. And, frequently we were talking before about that kind of ad hoc exploratory sort of processing. And it's so nice that, maybe your initial questions that you start to ask of some data start off in the command line, and you start to build up these pipelines that give you some information. If you discover that you're asking the right questions and you need to go further, it's so straightforward to then take your Ruby solution from the command line, turn it into a full-blown script. And the two things feel the same. It both feels like Ruby. It doesn't feel like you've gone from suddenly this, you've gone from your command line processing approach, and then you suddenly have to completely rethink your whole problem to bring it into Ruby. That continuum is really great. And then, eventually you might turn something into an application that you're using every single day rather than a one-liner that you run once. But you can start from that one-liner and progress right through to the application. And Ruby can take you on that whole journey, which is one of its greatest strengths, I think.
Yeah, that's beautiful. So Ruby scales in that way. It scales from the exploratory, just quick one-off command line into a production program gradually. And then it's a refactor, not a rewrite.
Yeah, absolutely.
Also, the Ruby community, with its good idioms and the consistency of there is a right way to do it. There are many ways to do it, but one of them is more Ruby than the others. That gives people guidance in how to refactor it, unlike Perl.
Yeah, absolutely. That, there is a right way to do it for a given situation. I think that's the thing, isn't it? That you can always look at a variety of solutions at that particular moment and say that is the most sensible one. These other ones would be a mistake, but it's for the same problem in different contexts. There are different approaches, and it has that flexibility.
Everything's a trade-off, and different approaches have different trade-offs. My favorite thing when you're moving, I love that Ruby is just malleable, and you can just roll it from these command line things up into these things that start existing in a script file. And for me, I just get this silly grin on my face when I have this bit where I'm doing Ruby-E and I'm transformungling the data, but I'm also doing -R and I'm requiring a class file that knows how to read and write the data that I'm manipulating, at least at the low level. So I end up, now my -E is just, hey, for each record, do this, do this, do this, do this, because you could just say, data.new $_ and you're done. And
yeah, absolutely. You've created a kind of command line interface to that data where what the actual questions you're asking and the processing you're doing are different every time, but you're doing some initial processing in the same sort of way. And the command line is a really brilliant interface for that.
Yeah. It's that moment when you realize, okay, I've got a common data model, but every time I touch it, I need a completely different application. And so, you write the application with -E and you pull in your data with -R.
I thought of the answer to a question of an interesting thing.
Excellent.
Processing that I did. So, we do a lot of packaging for food brands, like packaging design. And often you need to print something onto those packs, maybe like a unique code if you're doing some kind of competition thing. So we had this scenario where we had to print a unique URL onto the packs. It's all fine. It was for some kind of redeemable coupon. Not amazingly interesting, but they designed the packs that had the space where the URL goes. And before the packs go to print, the day before they go to print, we discovered that the designer has left about 10 characters for the for the URL that needs to go on these packs.
Oh no!
The unique URL that the coupon people have generated is about 150 characters long, and oh, by the way, it's on 50 million packs. So, who wants to go and put those URLs into a URL shortener? So, I just did this very quick one-liner, took 5 minutes that used, you were talking about the R flag just then to require libraries from a one-liner. So, bit.ly to require the bit.ly gem, RCSV to require the CSV library from the standard library, and then, chew through the URLs, for each URL you find in the CSV, replace it with the bit.ly version and write the file back out again. So 10 million files, quite a big file, but it's a CSV, so you can process it as a stream, and then, it has to make the request to bit.ly, so it's not the fastest thing in the world, but it was really quick to write. Surprisingly enough, I've never had to do that again. So, it was completely suited to a one-liner, and you just can sit there and chew through it, and problem solved. You get to send those URLs, send the file to the printers and save the day, which it always feels quite good when you've got this panicked problem and you can save the day.
I was waiting for you to say that you had 50 million unique random strings, and the day before you went to press, somebody found out that every swear word in the English language was in the URLs, and those URLs needed to be skipped.
We have also had that problem before.
Yes.
As an irate customer writing in and saying, "Why is this word on my pack? My children read it, went to the website and entered it." So, we now have a words filter that runs before any of these random codes that we generate.
I bet those kids were excited.
Yeah, the most exciting.
Mom will never know.
The most exciting thing you'll read on a yogurt pot, I would imagine.
When I'm doing this kind of like exploratory text munging coding, I often find it helpful to enlist some kind of tools to give me more of like a sandbox environment, like a workspace environment. Like those who watch Ruby Tapas know that I'm a big fan of the Seeing is Believing gem. Before that, I used the XMP filter gem, where I would, in my editor, I can write a little bit of code and then execute it and see the results pasted in inline in special comment blocks, and then sort of fiddle with it a bit and add to it, and then execute again with key binding and see the results filled in. What kind of tools, if any, do you use? Tools or practices do you use to sort of have that sandbox experience where you don't have to like go back to square one all the time?
I can't think of any tools necessarily. The practice I do is, always to work on a subset of the data, if only for the sake of my own boredom. I don't want to chew through a large data set. So working on some feasible subset of the data, even if that's only, putting in the second part of your pipeline head 10 or something like that to, just work with the first 10 lines, that until I get to the point where I feel like I've got a solution. But generally I find that, especially for the stuff from the command line, it's really easy to do that in an iterative sort of way, because each step of the pipeline produces its own output. So I kind of, you start off with a cat of a file, or, the initial command, and you see it, you look at the shape of it, and then you think, okay, the next step is this. And then you start to do that first step, and then you see the output. And it's a really good feedback loop. You get to see at each stage, okay, that command that I've added into the pipeline chain has manipulated the data in this way. And, oh no, that's clearly a mistake. I can go back. And I find the feedback loop of that sort of development already quite tight. And so long as it's performant enough that I'm not, distracted as soon as I hit enter because it's taking me, 10, 15 seconds to run rather than less than a second, I feel like this is already quite well suited to that kind of feedback.
So do you generally work at the command line rather than at like a IRB or pry command prompt?
Yeah, usually. Like even if it's something that I'm going to turn into a script, I've usually inevitably started from that kind of exploratory testing, even if I don't realize it yet, because that is just my first instinct to go there. And then, pry for maybe if there's a particular Ruby step within that process that's quite complicated, maybe I'll play with that in pry. But yeah, I find the command line a quite unnatural environment for that sort of working.
I will do that, sense. But I will also, if I get to a point where I just don't know what my data looks like especially if the client has supplied some data, so I genuinely don't know, I have a good reason for not knowing what the data looks like yet. And so I'll end up writing the first 20 lines of the script to open the file, read it in, parse it into chunks, But I'll do that as IRB and then -R to bring that file in. And then I can investigate a record or two and go, oh, it's pass_word. Like nobody else in the world does it. Okay, that's not bad. Exit back out, and then, if it's something that simple, then yeah, you can just do it with a put statement. But if it's like a nested JSON string, like hash, object of object of objects, sometimes I like to jump into IRB that way as well.
Well, that kind of array of something, it was going to be one of my picks, but there's an amazing library by Peter Solnitzer. I'm sure I've mangled his name, called Transproc. I don't know if any of you guys have played with it, but it's basically a way of defining transformations applied to data in it's a very functional programming style. So you basically compose together these different methods, each of which perform a particular transformation on the data. And it comes with things like map values for hashes and, map array to apply a particular function to every element in an array. And you can basically write these very short little functions, for renaming the keys of a hash. So, you have that input where the only input in the world where it's pass_word. So one of the steps of your transformation that you're doing is to rename that key to password, because, the system you're importing to expects it to be password. And you can just compose together all of these different small methods that are obviously highly reusable because they're quite abstract, things like renaming keys and nesting hashes. So taking a flat hash and nesting it into multiple hashes and things like that, and unnesting and all sorts of things like that. So I do a lot of kind of importing and exporting of data, and I find transproc is amazingly useful and makes me 100 times more productive than I would otherwise be.
That's awesome.
And it's kind of that same philosophy as on the command line, where each step of a text processing pipeline on the command line is performing this one transformation to the source data, and it doesn't have to concern itself or it doesn't know that it's in a pipeline chain or what the other bits of the pipeline chain are doing. It just knows some data is coming in and I need to do this one thing to it, which makes it, it's highly modular, highly reusable. And transproc has that same thing, but applied to kind of data structures that are in memory in Ruby, which, when you have that hugely nested data structures, or once you've passed your CSV, what do you then do next? I find it's really, really useful for that stage. It's really great.
Awesome.
One thing that came to mind when Dave was talking about his tweets, I wonder, do you ever use this text processing stuff on kind of visual, like textual visual things? What's coming to mind for me is I've done Game of Life with several of the companies that I've done coaching for. I've used it as exercises. I've run a couple of code retreats. And in a lot of cases, what happens is people either want to represent the live cells and the dead cells. I'm not sure if you're familiar with the exercise,
yep.
but the live cells and the dead cells as different characters, or they use it to delineate a map or things like that. Could you use some of these techniques to basically store your information as far as which cells are live or dead, or, some other visual representation in text, and actually have that be the canonical version of your data as well?
If you imagine that, what you're essentially describing is a kind of save game state, right? Like you can set the initial conditions of the board. So that's a really useful thing, because the text, the kind of the ASCII art version of the board is then humanly editable in a really intuitive way. But then it would be really straightforward to parse. It's almost not text processing because it's a grid, isn't it? That's but yeah, that kind of thing of thinking about a novel file format for your data that enables someone to more effectively edit it if it's going to be human editable. You don't. I think it's very often a first resort to go, I'll store the grid as an array of arrays, and then I'll just dump that as a JSON file or something, and that will be my save file. But that's it's a more imaginative solution, isn't it? That the representation on screen also becomes a representation in a file, which then makes it really straightforward to edit, and you don't have to think differently when you're viewing the game as it's running to when you're editing the starting conditions. That's a really, really nice thing, I think.
Have you ever run into a situation where you did find yourself wanting to do something in parallel, like either parallel I/O, or splitting something across CPU nodes, or splitting something across even machines? Did you ever run into something that was big enough or slow enough for that?
Absolutely. So there's a few different levels to that, I guess. So the first thing that is great about especially the command line processing is that it's parallelized already. So if you think about the different commands in a pipeline chain, as soon as you hit enter on the command line, all of those commands start. Sometimes people think about it as though the first command runs and then it passes its input to the second, and then that finishes, and that it's sequential in that way. But it's not. All those commands are running in the same way. So if you've got something that's quite CPU bound, those other processes that are processing the data later on can be doing their thing just as at exactly the same time. So often that's enough. That gives you some kind of performance, and that's really great. And then there's a few extra things you can do. So you discover that one part of your text processing pipeline is really slow. Well, if you're doing kind of streaming data and processing things line by line, that's really trivially parallelizable by working on it at the same time, working on different chunks of the file in different processes. So xargs, the command that lets you take lines of input and pass them as arguments to another process. That has a really useful P option, which lets you specify how many processes to invoke. So that can be commonly useful. Say you've got something that's something that's a step that's maybe grepping, or you've got a Ruby step that is quite CPU bound because you're doing some kind of complicated text processing there. You can then run 4 at once if you've got 4 cores on your machine and parallelize just that one step without then having to consider parallelization from within your Ruby script, which then becomes a lot more complicated. Your Ruby script, it just knows that it's processing some chunks of data. It doesn't know whether it's the whole file or a quarter of the file or whatever it is. That's really useful. And also the GNU command parallel that lets you invoke multiple instances of a command. That's also at the same time. That's also really useful. I've not yet encountered a problem that's forced me to scale up beyond that to multiple machines. That's maybe the point where you do genuinely have a big data problem, and this approach is no longer the right one, maybe. But I'd love to know if this approach is scalable to that extreme level.
Have you run into, in a similar vein, cases where you have to fan in data or fan data out, by which I mean, like, you might take a database full of customer, it's not really text processing, but okay, whatever, CSV file full of customer records, and we've got the customer name and the customer's address and then the customer's phone 1, phone 2, phone 3, and fax, because we still live in the 19th century. And you want to emit a customers list and an addresses list referencing those customers and a phone numbers list referencing those customers. That would be like the fan out version of it. The fan in version, of course, is that somebody has built out 2 separate files that are both keyed by the same index, that really they shouldn't be 2 separate files. So you will actually want to munge them together into a single output. Do you run into that very much?
Yeah, occasionally. So there are some great command line tools for that, like join, for example, that lets you basically perform, as you would in a relational database, a join between 2 files. So say those CSVs that you're fanning in, they've both got an email column or a user ID column or something, that's the thing that you're joining on. It's really trivial to then, as maybe the first step in your pipeline, combine those together and then continue to process it in a streaming way, but be able to do those joins together, which is really useful. I can't think of a time when I've encountered the opposite problem, kind of fanning out. I don't know whether anyone else has, needing to split things out into multiple files, but it's generally somewhat trivial to do that if you're as you're going along, just instead of writing everything to standard output, have a few different file handles that you're writing to. The fanning out is probably generally a more straightforward part of the problem than the combination bit at the start, especially since often that involves getting everything in memory at once.
Yeah, I run into this more often with database transformations than I do with text processing. And it's the gotcha isn't reading from multiple sources or writing to multiple sources. The gotcha is how much stuff do you have to hold in memory so that you can pivot correctly, right? Because you might not, totally. the 2 files might not be indexed. When I say indexed, I mean like they might have an ID column as opposed to like the line number indexing. Like, if line number indexing, you're good to go. Just join the files together and down the road you go. And if they're joined by IDs, then now you've got this mess where, okay, I need to load this file and process it and hold it in RAM. Now load this other one and then process it. Now munge those 2 data sets together before we do our output.
Yeah, that's definitely generally the tricky part, maintaining your ability to stream data. But it depends on the shape of the data generally.
Yeah.
This has been really interesting. And it's something that I think a lot of times we just kind of take for granted. I'm going to have some pile of text and I can cut through it this way or that way or the other way.
In fairness, I've been sitting on my hands through most of the show because I spent the first 5 to 10 years of my programming career doing nothing but munging text and doing things like on a 16K computer, you can't fit all the zip codes in America into memory. And so if you want to write a phone billing program, you have to put a diskette, 180 kilobyte diskette, into drive B or drive C or drive D on one of the really old Tandy machines. and write your program to read stuff than go look up zip codes out of the disk. So that's just a tiny example of how boring I could have been in the show.
But no, it's exactly that kind of approach. Like, I think developers who've started in the last few years are unused to a world in which resources are constrained because they have effectively infinite quantities of CPU and memory and disk at all times. And I think that it's partly that thing that leads the assumption that you have a big data problem because, well, no, you just need to be inventive and figure out the way to cut the problem in a certain way that enables you to process it. And I worry that those are lost techniques, especially among younger and more junior developers.
Yeah.
All right, let's do some picks. Avdi, do you have some picks for us?
I believe that I do. So first off, I'm going to go ahead and pick Rob's book. He was nice enough to give me an early look at it a while ago. And it's really good stuff. There's some coverage in there of techniques and classes that honestly I had not seen given any decent coverage in Ruby books before. Things like the string scanner class and stuff like that and RGEF and stuff like that really deserve more attention. So Rob's book is great. Definitely pick up a copy. It's fun stuff. Now, if you want to play with these kind of techniques and you are just sort of at a loss for a fun data set to play with, there's an email newsletter that I discovered recently called Data is Plural. And basically once a week, the author of this newsletter sends out a curated list of links to interesting public data sets. So just to cite the most recent example, we have an arms transfer database, which tracks the international flow of major weapons. We have somebody's got a nearly 70,000 images from candidates' social media accounts. Okay, that's not really text processing, so maybe let's see. There's a National Registry of Exonerations has a dump of all of the criminal exonerations in the United States. There's a listing of major breaches of HIPAA-protected health data. So this is a dump of the breach events. And then finally...
the events or the actual data?
And then finally, there's a public record of the contents of the official United Kingdom wine cellar, all 34,052 bottles. So... it's a fun, again, it's called Data is Plural. It's an email newsletter once a week where the author just sends out interesting public data sets. So often you have something you want to play with, but you can't find a good data set lying around. And so there's a good source of them. And finally, I just got back from RubyConf. I am biased because I was on the program committee, but I heard from a lot of people there that they really felt like it was one of the best RubyConfs ever. And I've seen that the videos the Confreaks recorded are already going out. There's already a bunch of them up.
Oh,
so
wow.
by the time this episode ships, they might even all be out. So check that out. There are a lot of really great talks. I think we had some fantastic speakers, and it was a really great program. So we'll put a link to that in the show notes. And that is it for me.
All right. Jessica, do you have some picks for us?
Yeah, I do have a pick. So I'm in San Francisco this week in the Stripe office. And last night I got to go to Papers We Love, which is a meetup. It started in New York, but it's been franchised. So I'm going to pick Papers We Love. If you go to